So there's two ways that you can measure angles. There's degrees, and degrees is the one you're most familiar with. Okay? And then radians is the other one. And in Desmos, whenever we're answering questions and finding sides and finding angles, most of the time you do want to be in degrees. When you get to Math 4 or pre-calculus or something like that, radians might be a time, there may be a time that you need to be in radians on Desmos, but for right now we're just going to focus on degrees. But I want to show you what the difference between the two are. So the first question, it says, how many degrees are in a circle? Okay, let's just think about like what degrees look like. I know that 90 degrees looks kind of like that. Do you agree? I know that how many degrees is like on a line right there? 180, because that's called a straight angle. So if I start and I go all the way around a circle, it's kind of like doing 180 and then another 180. So there are 360 degrees in a circle. Okay? Now, to relate how that has to do with radians, let's talk about the circumference of a circle with radius of 1. Okay? So the circumference of a circle is 2 pi r. Okay? When the radius is 1, if I just put a 1 in the place of r, I get 2 pi. Okay? So 360 is the degrees all the way around the circle. 2 pi is all the way around the circle. Now related to circumference. What that means is that 2 pi radians is 360 degrees. And that's really, really important to know. Okay? Now, whenever we draw a degrees, you always start over on this side and you go all the way around. So 360 goes all the way around the circle. Okay? And I just said that that was 2 pi. Okay? Well, let's talk about pi. Okay, I'm going to draw like an x and a y axis in here. And I said you always start right here. If 2 pi is all the way around, what that means is pi is half of that way around. So pi would go from here to here. Because 2 pi is all the way around, pi just goes halfway around. Okay? How many degrees is that? 180. This is another one that's really, really important. Especially this one you should remember. Okay? Always remember that pi and 180 correspond to each other. Okay? I'm going to show you some of the other ones that are just special ones, and then we're going to talk about how you actually change it back and forth. Okay. Pi was halfway around the circle. Pi over 2 means half of that. So we would come here and go to here. So that's 90. That's 90 degrees. Okay, pi over 4 is actually half of that. So if I draw it, it's going to start here and go just like halfway to there. It's half of 90, or half of the pi over 2. So it's going to represent 45. Alright, pi over 6 and pi over 3, there's not a good way to draw them. I will tell you that pi over 6 is smaller than pi over 3. So I just drew it a little smaller and a little bit bigger. Okay? And I'm just going to tell you that pi over 6 is 30 degrees and pi over 3 is 60 degrees. Now, when you get to other math classes, these are going to be some important special angles that you're going to have to memorize. Okay? And the way I memorize them is look at the pi over 3 and the pi over 6. They're opposites. You see how that 6 has a 3 and the 3 has a 6? They're just opposites. And the pi over 4, it has a 4 in it, so that's the 45. either you need to understand the process of how we got it, or just memorize those. Those are important. For now, I just wanted you to see what it would look like when we draw an angle, and I just wanted to talk about those special ones. Now, there's actually a process that you're going to use to change them, and that's what we're going to do next. So what you do when you change it from degree to radians, basically, is you multiply by pi over 180. Okay? So if I'm going to change 120 to radians, I'm going to multiply by pi over 180. Now, in Desmos, what that means is not that I'm actually going to multiply by pi over 180. Okay? So let's get rid of all of this stuff here. What it actually means is I'm going to put 120 divided by 180. I'm going to change it to a fraction. And then I'm just going to put a pi beside of it. Okay? So I don't put the pi in Desmos. Really, I just do 120 divided by 180 and put a pi with it. And so I got 2/3 pi. And that's the answer. Okay, so for number 2, I'm going to multiply by pi over 180. So in Desmos, I'm going to put 240 divided by 180. I'm going to come over here to the fraction and change it to a fraction. And then I'm going to put a pi with it. Okay, try 3 and 4. Okay, so on the next section, so when we go the other way and we want to convert radians to degrees, it says multiply by 180 over pi, so you multiply by the opposite. Now, I personally think that it's easier if you just substitute what pi is. We know that pi represents 180 degrees. And if you substitute that in for 180, it makes it really simple. So you're going to put 2 times 180 over 3, and then whatever you get, that's the answer. You don't have to multiply or whatever it tells you to do. You can just minus. You can just put 2 times 180 divided by 3, and you get 120. So basically, I'm just taking that 180 and putting it in the place of pi. So 13 times 180 over 6. 13 times 180. And you can put it all on top or separate the way I have it. It'll work. And you get 390. Okay, so now that we know how to change them from radians to degrees and degrees to radians, we also want to be able to graph the angle. And we want to look at a graph and be able to know what the angle represents. You always start on the positive x-axis. Okay, that means that over here on the x-axis, you're going to start right here. And it doesn't matter if you start at the 1, 2, 3, or 4. That's not the important part. The important part is we're going to start right there. Okay. If the angle is positive, then you start there and you go up. Okay? And that is counterclockwise. If you think about the way clock goes, that's backwards from the way the clock goes. And so that's counterclockwise. Okay? If the angle is negative, you still start there, but instead of going up, you go down. And that is clockwise. So you always start over there on the positive x-axis. If it's positive, you go up. Negative, you go down. The other thing that you need to know is that whenever we draw this angle, it might say what quadrant is it located in. Okay? And so what I wanted to do is to show you the quadrants. The quadrants go along with what's the positive one, but it never changes. It doesn't change. This is quadrant 1. quadrant 2, quadrant 3, quadrant 4. Okay, so if it asks what quadrant it's in, think about those quadrants, and then it's wherever it is. Okay? So let's look at some problems and see how all of that relates. So number 9 says 250 degrees. Okay? First of all, I know it's positive, so I know I'm starting here, and I know I'm coming up. Alright, when you start figuring out where you should draw it, you want to think about what you know. I know that if I go from here to here, that's 90 degrees. I know if I go from here all the way to here, that's 180 degrees. If I go from here all the way to here, you might not know it, but it's 270. Because it's 180 plus 90, because that part right there is 90. And then if I keep going, I know that I'm going to end back up at 360. Okay? And so those are some important ones just to know where they are. If I'm going 250 and I'm going to go this way, and I know this is 180 and this is 270, I know 250 is going to be over here somewhere. So what you do is you draw your little circle thing, and then you draw an angle. Your angle is just a line that sort of represents it. So that's what it's going to look like if I just say draw the angle. And then once I have it drawn, I can figure out what quadrant it's in. Start here, 1, 2, 3, 4. So what quadrant? Okay. The next one says negative 320. Okay. Alright, negative means that I'm going to start here and I'm going to go this way. Okay. Alright, if I go just to here, I know that's 90. If I go to here, that's 180. If I go to here, that's 270. And if I go all the way back, that's 360. So where's the 320 going to be? Somewhere in between there. Because it's going to go all the way to 270 and a little bit more. What quadrant is that going to be in? 1. Because it starts here at 1 every time. No matter whether the angle is positive or negative. Okay, we're going to go ahead and do these two, and then we'll come and look at the next ones. So 390. Okay, it's positive, so I know I'm going to come around this way. It's more than 360. How much more than 360? Well, subtract it. So I know it's 360 and 30 more. So that means I'm going to go all the way to 360. And I'm going to go a little bit more. Does that make sense? So it's possible it might be more than just one circle. It might be more than one circle. And so that one would be quadrant 1. Okay. One more. Okay, this one. I know I'm going to go 360 and a little bit more. When you subtract to see how much more, don't put the negative on it. Because I'm just trying to figure out how much more I need to go past 360. Okay? It's negative, which just means I need to come around this way. So that would be 360. And then I need to go a little bit more. And that means that it would end up being in quadrant 4. Now, on the ones that are radians, what you have to do first is you have to change it to degrees. But then you do the same thing. Okay? So I think about 5 times 180 divided by 6. I think you get 150 for that. And then you go and draw it. So I know that 90 is there. So 150's got to be just a little bit more. Not quite 180. It would look like that. And that would be in quadrant 2. So on 15, if you change it, you get 480. And what you find out is that's, if you subtract from 360, that's 120. So that means you go all the way around to 360, and then you go 120 more. So it ends up being around there, which is in quadrant 2. On number 12, if you change it, you would get negative 120. Remember that negative means I come down this way. And I know if I go to there, that's 90. It's a little bit more than 90. So that would be quadrant 3. And the last one is a little bit tricky. Go ahead and change it. You get negative 630. And what you find out when you do 630 minus 360, you get 270. So what that means is you go all the way around 360, and then you go 270, 90, 180, 270. It ends up being right there, and then that's just the way it looks. When it falls on the line, it just looks like that, and it's not a quadrant. We would say y-axis here. If you really had to figure out where it fell on the y-axis instead of in a quadrant since it's on the line. Now, last thing that we want to do is we want to figure out the measure of the angle. So it's one that they have drawn for us, and what we have to do is figure out what angle it is that is true based on their drawing. Okay? So, in number 17, it started here like always, and it went to there. So I know that if I start here and I go there, that's 90, 180, and then 270. So I know that's just 270. If the answer choices were in radians, then you just change them and figure out which one's 270. Okay, let's look at this one. So this next one, it started here and it went this way. That means my answer is going to be negative because it went that way. Alright, I know that it went 90, 180, 270. So it went 270. But then it went 20 more than 70. 270. So it went 270 and 20 more. So it was negative 290. So just take it in pieces. Okay? Number 19 is really strange because there's lots of circles here. So start on the inner circle. And let's go all the way around. Okay, when I go to right there, I know that's 360. Okay, let's go again. So starting there, let's go all the way around. There's another 360. Alright, and then if I keep going, I'm going to stop right there because I know that's 180. And then I've got to go a little bit more. So the question is, how much is a little bit more? Alright, I know this is 75. And I know this whole thing is how much? 90. So I can take 90 minus 75. Figure out that this part right here is 15. And so to figure out my angle here, I'm going to take 360 and 360 and 180 and 15 and add all that together. And I get 915. Okay, so we start here and we go 360, right? And then we go 90 more. And then I've got to do something here. So if that's 40, that's got to be 50 because you do 90 minus 40 to get that part. And then you add the 50. So that's 500.